Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626, Unit 3, Electric Drives and Elevators. There are the types of bearing. So these are the types of bearing, its application, explanation and a diagram. So first is the plain bearing. A plain bearing is a bearing in which two surfaces slide past each other. As a rule, a lubricating fin facilitates this sliding process. This sliding movement takes place directly between the sliding layer of the bearing body and the respective mounted part. Lubricants stored in bearings or supporting are applied to a solid layer to a supporting body. Ensure lubrication. Almost all industrial sectors use plain bearings because of their versatile and the specific properties. Application is due to the versatile property. Plain bearings are used successfully in almost all the industrial sectors. Plain bearings are used for sliding, rotating, oscillating, or reciprocating motion. In sliding application, they serve a slide bearings, bearing strips and wear plates. In this application, the sliding surface are usually flat but cannot be but also be cylindrical linear rather than rotating. Rotating applications involve cylindrical surface and one of the two directions of the travel oscillations and reciprocating. Applications involve flat or cylindrical surface but bidirectional travel. Second is the rolling element bearings. Rolling element bearings place balls or rollers between the two rings or races that allows motion with the little rolling resistance and sliding. These bearings include ball bearings and roller bearings. Ball bearings are the most common type of rolling element bearing. This element can handle both radial and thrust loads but are used where the loads are relatively small because of its structure. So this is the explanation and here is the application of the roller bearings, and it is used in wide range of application from the heavy equipment and machinery to the power generation, manufacturing and aerospace. Next is the jewel bearing. Jewel bearing are the plain bearings with a metal splinter but that turns in a jewel nail pivot hole. They carry loads by rolling the axis slightly off the center. They use a metal splinter with a jewel lined pivot hole. The importance lies in the fact that they can be machined to very high accuracy. They have low and predictable friction and their hardness gives them very low wear. They are known for operating in sealed environment for decades with the no servicing, and application are low meters, gauges, meter indicators, aircraft instrument, gyros, watches, clocks. Fluid bearings. Fluid bearings support the load using a thin layer of gas or liquid and can be classified into two types: fluid dynamic bearings and hydrostatic bearings. Fluid dynamic bearings use rotation to form the liquid into a lubricating wedge against the inner surface. In hydrostatic bearings, the fluids, usually oil, water, or air, rely on an external pump. Fluid bearings are used in high load, high speed or high precision applications that ordinary ball bearings either couldn't handle or would suffer from increased vibration and noise. Magnetic bearings support the moving parts without physical contact, instead relying on magnetic fields to carry the load. They require continuous power input to keep the load stable, thus requiring a backup bearing in the case of power or control system failure. Magnetic bearings have very low. They are used in industrial machines like turbines, motors, and generators. So here is the last type of flexure bearing. A typical flexure bearing is one part joined to others like a hank in which motion is supported by a load element that bends. These bearings require repeated bending, so material selection is a key. Some materials fail after repeated bending, even at low loads, but with the right materials and bearing design, the flexure bearing can have an indefinite life. Another notable characteristic of this bearing is its resistance to fatigue. Many other bearings that rely on balls or rollers can fatigue as the rolling elements flatten against each other, and applications are sensitive precision measuring equipment. So next is the size and rating of the motor. While selecting the motor for a particular application, the motor and load characteristics should be known. Following factors are the important while deciding the size and rating of the motor for a particular application. First is the starting conditions of the load. Second is the matching of the speed torque characteristics, and third is the nature of the load. So starting conditions of the load. The torque requirement is different for various applications. Example for electric traction, conveyor belts, hoist. The starting torque required is large and it should be provided at the low speed. So a motor with the high starting torque is to be selected. The motor starting current should not be very high. For applications like water pump, lathe machines, drilling machines, starting torque requirement is medium. The motor rating is selected considering the above factors. Second is the matching of the speed torque. The basic problem in choosing proper motor for a particular application is in matching the speed torque characteristics to the load requirement. The load mechanism should be fully known, that is, the requirements of the load should be known properly. Steady state stability. For the stable operation of a motor, if the load torque demand increases, the motor speed decreases. The decreased speed causes motor to take the more current from the supply side. Thus input power increases and the motor torque increases and the motor meets the increased torque demand. Reverse happens if load torque demand decreases. Consider a motor which supplies mechanical power to a particular type of the load. This motor load system operates in the steady state only when the motor torque equals. So the load torque equilibrium point at any disturbance in load increase or decrease causes change in the motor speed. So in the figure in which motor load characteristics is shown, the equilibrium point is said to be stable when the operation is restored to the equilibrium point even if there is some disturbance on the load or motor. The equilibrium point in the figure is a point A. At this point, motor and the load characteristics are interesting and motor torque is equal to the load torque, that is Tm is equal to the Tl. The speed of the motor is in rpm at this condition. Suppose a small disturbance causes reduction in the motor speed from n to n1. At this speed n1, the motor torque is greater than the load torque. The motor is now accelerated and operation is restored to the point A. Suppose a small disturbance causes increment in the speed from n to n2. The option point C. At this speed n2, the motor torque is less than the load torque. The overall operation of the motor is thus steady state stable at point A. Now consider the same motor, this time supplying the mechanical power to a different kind of load. Refer to the figure. Next, the operation is stable at point A. Tm equals to Tn. Suppose a disturbance causes reduction in the motor speed from 8n to n1. At this new time, new speed n2, the motor torque is less than the load torque. The motor further decelerates the operating point, now moves away from A. Similarly, when a small disturbance causes increase in the motor speed from n to n2, the motor torque becomes greater than the load torque and the motor further accelerates and operating point now moves from A. Thus we can conclude that point A is unstable point of equilibrium. From the above two cases, we can say that for a stable operation, the load and motor characteristics should intersect at 90 degrees. If these are not intersecting at 90 degrees, the operation is unstable. After the point of intersection of characteristics, the motor torque should decrease with the increase in speed and the load torque should increase with the increase in speed. We can again stress in the figure. So this corresponds to the stable operation. Let us take a practical example now. Suppose we want a motor for driving a fan. The specialty of the fan load is that its torque varies to a square of the speed. We can choose the induction motor or the DC motor for this purpose. Next is the nature of the load. There are four types of load. Load torque remaining constants irrespective of the speed. Example, hoist crane. Second is the load torque proportional to the speed. Example, fluid friction where lubricant is used. Third is the load torque proportional to the speed square. Example, air and fluid friction such as blowers, fans, water wheels. Fourth is the load torque proportional to the inverse of the speed, inversely proportional to the speed. That is, load torque decreases with the increase in speed. The characteristics of the above types are shown in the figure. In practical world, a load may have combined characteristics of the above basic types. So here is the load versus speed characteristics at the different point A, B, C, D. It is shown. Thank you.